Okay. Hello, everybody. Cornbelt here. This is my Ergo Hack 6 project, Sigma subscriptions. Subscriptions on Ergo. Okay. The goal during Ergo Hack was to get a proof of concept, write the smart contracts, create a framework to interact with Ergo, and using this framework, implement a UI to manage the subscriptions. So key components of my implementation, there are 3 different box types: a configuration box, a subscribe box, and a subscription box. There are 6, technically 7 transaction types: create and edit, configuration, a create service transaction, a subscribe transaction, a renew transaction, cancel, and collect. Let's dig a little deeper. So, configuration transaction. Config boxes were used to create and manage the subscription settings. They're used as data inputs to ensure the proper setup of subscriptions. They should contain the following: the service config NFT, which is minted during the creation. Service address, this is where payments will go, and this is also the address that's used to edit any of these settings. The hash of whatever subscription contract is being used. Future implementations could use multiple versions of a subscription contract, so that was necessary. Also to ensure that fees were actually sent to the proper address. Service fee in nanoergs, service length in milliseconds, service name, and the service description as such. So once you've created a configuration, you can use that as a data input to create a service, which effectively just mints a token. So what we do here is we pass service tokens are stored in the subscribe box, with a reference to the service configuration NFT. By default, there's 10 billion tokens minted. This could be edited to whatever. I thought that was a significant amount. Would ensure, but in theory, you could limit this to whatever you wanted. If you want, say 100, whatever. That's possible as well. So how the subscribe process works. So in a subscription, boxes are created when the subscribe box is spent. So this results in 2 tokens being minted. One of them is stored in the subscribe box, and the other is sent to the subscriber's wallet. This is how you tie a subscriber to a subscription. The subscription box should contain the following: one of the service tokens in the subscribe box, 1 subscription token minted during this, the service config reference, and the start date, which is a Unix timestamp in milliseconds, and the end date, also timestamped. So in order to renew a subscription, the subscriber must send the correct fee along with their unique subscription token, which is how they're allowed to spend the existing subscription box. This subscription box is then recreated. The previous fee is sent off to the service address set in the configuration. So you can change that. So if you say you wanted to change which address you're running the service under, it allows you to do all that. And then the start and end dates are adjusted in this new subscription box. Easy peasy. So say you don't like whatever service you subscribe to and you want to cancel. This cancel a subscription, you must hold the unique subscription token in whatever wallet you're trying to interact with. If the service start date has not been reached, there is a feature you can set service dates to be in the future if you wanted. So say you have a bunch of people subscribe and the service doesn't start till a certain date or whatever, and people want to cancel before then, they can get a full refund. Or if you've renewed during an existing one, and the renewal period hasn't started yet, and you decide you want to cancel, that's possible. If it is during an active service time, and you start and end dates fall within the current timestamp, then a partial refund is issued, and whatever percentage of the fee is remaining is sent to the service. During a cancel, the service token and the subscription tokens are all sent back to the service. There were several ways I thought about handling this. I thought about just burning them, but I didn't know if keeping these tokens around would be useful or not. I don't know. Anyway, that's for future implementations. All right. Collection process is really simple. So a service can force collect a fee if a subscription box service date is passed and they haven't renewed. And the authentication process. So a subscription is basically considered valid if there's an unsent subscription box, which contains one of your service tokens and a unique subscription token, which is tied to, so whoever holds that, the other token is considered a valid subscriber. Some of the outstanding issues that came up during my implementation, having one subscribe box really limits the number of possible subscribe transactions that can happen. Really, I think it's one per block because it needs to be spent. I believe it would be possible to create a backend because I didn't implement or want to use the backend for this particular implementation. You could collect those. Say you run a website and you have a database, you could collect and send lump transactions. So you're spending that one box chained. I think it's possible. I don't know for sure. Another issue, like I said, is those service tokens floating around in a PTPK address. Probably best to burn them because if they're ever sent somewhere else, they can be used to create fake subscriptions. One weird thing was in the subscription token emission, because if you send it to two different addresses, it's a non-standard minting process, which the emission number then is incorrect, or the emission amount. And finally, if configuration is edited and during the renewal process, because we don't remint that token, say you change the name is the old name, which can be a problem or confusing for people, but they could just resubscribe to, cancel and resubscribe. Or we could remint that token too, but then you have to wait to gain access, I guess. There's several ways you can handle it. And for this Ergo hack, I really just focused on payments in Ergo. So that will, in future implementations, you would obviously allow somebody to pay the service fee in a token of their desired. Okay, so with that, let's go over to the manager. Okay, so here's our manager UI. Two basic features. You can manage services and manage subscriptions that you subscribe to. Over here we got settings. You can change your network, API, and Explorer instances. If you want to run everything local. All right, so currently don't have any services set up. Here is testnet wallet. This is the wallet we're going to use to set up a subscription service that's going to be required to access this manager section of this site. So let's connect with this one here. I have it coded to accept this wallet address so we can get into the backend here without being subscribed. Let's set that up. All right, so no services. Let's create a new service. Let's call it Signal Subscriptions. The name, description. We'll make it a nice, generous 0.1 erg. Adjust your day, week, however long get it exact. It's down to the day. You can even get down to the hour if you want to do that, but let's just leave it at month or 30-day subscription. Here's our wallet address. This is address you will need. This is where our payments will go, and you will need access to this address to edit any of these settings or collect payments. Okay, so when we submit, it's going to build our transaction here for us. So this is the configuration contract address, and basically all this one does is store all our settings, and as long as we have access to that wallet that we set in R4, we can edit any of these settings. We're minting this configuration NFT, which is used for references in any of the future transactions. Okay. Remember the password. There. Signing transaction. All right, so we've sent it off. Let's look at it in the Explorer here. And it gets into the mem pool. Oh. Oh. There we go. Okay, so here's our output. We have our configuration. Token ID, NFT, there's only one. R4 is our address, wallet address for our service. R5 is the hash of the service contract, or subscription contract, so wherever the fees are stored. R6 is our fee, service fee. R7 is our length, milliseconds. R8, name, description. All right, so wait for this to confirm here. Okay, so our transaction is confirmed. We'll go back to manage our services. Here we have it set up. Name, description, everything. So because we have to mint the configuration token first, NFT, before we actually launch the service. It's a little bit of a pain, but you could probably chain these transactions, possibly, or run them eventually. I don't know. Anyway, this is the way it works for now. That's for later dates. If you want to edit anything before, go into the same editor, change all the settings. Go ahead and launch this bad boy. So here is our launch transaction. So this is sending to the subscribe contract address. We are minting our token here, which is just the name of the service. That bad boy off. All right. Look at it in the Explorer. And we'll sit and wait. Go. Okay, so our output here, we have our service token, 10 billion of them. Like I said, you could, the manager doesn't have a setting. I didn't implement the ability to cap that, but you could. The toolkit has features for that. R4 through 6 are just your standard token minting settings, and R7 is the configuration NFT token ID that controls the subscription. All right, so we'll wait for that to confirm. Okay, so our transaction was confirmed. Let's go back to our services. It's green, which means it's launched. Good to go. Here's the service token ID. This is what will need to be passed into any subscribe transaction. Well, that's all you need to send off to the toolkit. Here's a nice little handy dandy link that will build it on this manager side that I've implemented, so anybody can subscribe here if they want. So if all you wanted to do is just collect payments, for instance, set it up and now, like run access to a website or anything, you could just send them this link. Easy peasy. Let's see. You can edit anything at any time. So I'm going to set this up so it's requires access. So now the manager section will require that subscription to access it. So give me a second. Okay, so we have it all set up. Now we're going to act like there's somebody that wants to come set up your own service here. So if we were to make a new wallet, store one I have money in, that's wallet service. I have a little fee here for the subscription. All right, so we have this new service wallet, which we're going to create a new service under. Let's connect with that one. Over here, try and access services. So now it took us to that subscribe link. Subscribe to the service. So let's go ahead and do that. This is in the, so we're recreating the subscribe box with one less token. Min-erg being sent there. Here's the service. Min-erg with the subscription token, the unique one. We mint 2 of them. One of them sent to the subscription contract here. One service token is then sent there as well. We'll sign and do that. Okay, let's wait. Confirming subscription. Okay. We'll go back on here. And we have, let's look at our outputs first. One less token in our subscribe box. All the settings are preserved. This is our subscription token that was sent to us. These are the token minting standards. Here's one. Yeah. Here's the service token. Here's your subscription token in the contract box, start and end date, and the configuration reference. So we'll wait for that one to settle. Okay, so that transaction is settled. We now can link off to go look at our subscription. So here we go. We have the name of the subscription, the start date, the end date, like a month long, whatever the fee is, the status. And here's our unique subscription token. We can cancel it. Can't renew it yet. Technically, you could renew it. Contract won't stop you as long as it hasn't started. As long as the subscription has started, you can renew it. Which would just bump this up another month if we did the renew. But in the UI here, I have it blocked, so we'll cover that later. So if we look here in our wallet, there it is. There's our wonderful token. It said dash subscription is what this token minted name is. And here's where we covered where the emission amount is wrong. There's technically one more of these token IDs in the contract box. But it's a big deal. Okay, so now if we go back to our dashboard, we should have access here. Oops. There we go. Got in, now we have access. We don't have any services. We can set up a new one. Call this one my awesome service. Okay. We're greedy, so we're going to make it an erg. Let's make it a week long. Make it easier. Week. Okay, here's our wallet address. Let's create and sign just like we did before. All right, we'll wait for that to confirm, and I'll launch it too. Okay, so transaction confirmed. I want to go ahead and launch it again. Same process here. Wait for this one to settle. Okay, so we are launched. So here's all the same settings. Here's your token. So if you wanted to run it on your own site and manage your subscriptions there, and handle the transaction building, this is all you need. It's the token ID, and what you can do is go back. You can install the toolkit here and create an instance, whatever network and settings, and then this is really all you'd need is the subscribe. So you send a wallet with that token, and that will build the transaction for you. And then you can sign and send it, have them sign and send it, or however you want to handle that. So right now this is launched. It's ready to be subscribed to. I'm going to copy this link here. Okay. Oh, okay. So if you look at our subscribers, we currently don't have any. Let's create one. So if we disconnect our wallet here, let's do a user wallet. This would be the experience from the user side of it. Or money in there, one erg. Set up. Perfect. Okay, let's connect to that user wallet. Okay. Then now if we try to manage services here again, it's going to ask us to subscribe. All right, so what we can do is go to my subscriptions. You have no subscriptions. So I'm going to pop off that link here. We copied for our new service. Okay, so here's the subscribe. Let's go ahead and subscribe to this. Okay, subscribe successfully. So there's my awesome service subscription. Sweet. Go to my subscriptions. Go. Start date, end date, week long. You have one erg and a subscription token. A unique one. Okay, so what I'm going to do now is because we can declare start and end dates, I'm going to set up another one that allows us to renew. Okay, so I've set up 2 more subscriptions. Here's our first one that we just did, start and end date. Here is one that I backdated, so we could test the renew here. So it expires tomorrow. We can go ahead and renew that. Here is one that I backdated even more, and it's expired. You can renew because it hasn't been collected by the service. Why don't we go see what these look like from the manager side? So disconnect here and go back to our service. Connect. Still have our service here. We go to subscribers. Oh, look at that. We got 2 active and 1 expired subscription ready to collect. Here's the wallet address of the subscriber. Status, their unique token. But this one's expired here. Why don't we go ahead and collect this? Okay, so on the collect. Okay, so on the collect here, it's sending to our service address. We're getting both our service token and their unique subscription token that was stored in the subscription box sent to our wallet. Like I mentioned earlier, I think a better implementation would be to maybe just burn these. Here we go. Let's take a look at the transaction. It's indeed mempool. Here's our output sent to us, both tokens. We will wait for that to settle. Actually, let's do this first. So here, our service balance, 5.6. We'll keep that in mind. We'll wait for this to settle. Okay, fee collected successfully. Overdraw balance here. It's up 1 erg. Hey, we got paid 2 wheat. Here are ones that I'd canceled before. Once again, I think it would be cleaner implementation to just burn all these. This is my service token, and these are the 2 unique ones. Okay. Interestingly, this was a cancel here. That's why there's 2 subscription ones here. So if we go back to our service, back to our subscribers, we only have 2 active ones we've already collected. So then let's go back to the user side here. Go to my subscriptions. Hey, look at that. The one they've collected that fee. I can't renew it. Oh no. No big deal, but let's say here. Let's do this. Let's renew this one. Actually, let's cancel this one. So if we click cancel here, it's going to do a partial refund. So because we just subscribed, we're going to get 99% of it back. Here, let's go back 2 seconds here. I try to cancel this one. This one's pretty much done. You can see the partial refund calculation here. So only getting 0.13. It's nifty. If, for instance, you wanted to set up a service where the cancel only burned the tokens, and you wanted to collect all the fee always. I thought this was a better way to force the service to respect the subscription if you can cancel at any time. So, for instance, if you had a malicious service that just said subscribe here and then they didn't do anything for you, you could come to this manager here, download this manager, and interact with those contracts themselves without having to rely on them, which is nice. So let's just cancel this first one here. Each one. Look at the transaction more. We're going to send this box, the subscription box. We're going to send the tokens. These are in the subscription box. Sorry, we're sending the service token and our unique subscription token and the one that's in the subscription box to the service address here. We're getting our refund. Here's the dev fee. It's very generous. Might go up. Who knows if anybody ever uses it. All right. One thing to note about the dev fee is that is actually paid by the subscriber. Tacked on. It's not taken from the subscription fee. Okay, so let's look at the transaction on this side. Output going to the service address. Correct fee, refund fee, and then whatever's owed to the service. That fee. We'll wait for this bad boy to settle. Okay, canceled successfully. Go to our subscriptions. We only have one. Interestingly enough, here is the one that the service has collected. I think, yeah. So this is the token that's still in our wallet from the one that was collected, which, you know, that's why I thought maybe it's best when they collect it. So it is sent back to the service wallet, because then you could, if somebody tries to connect and authenticate, you can say you have a subscription at this point, and it still all ties back. Once again, it's kind of out of the scope of this particular project. But if somebody wanted to implement this on their own, that would be a better way to handle it. Okay, so let's renew this one. So it ends March 4th, so our next start date should be March 4th if we renew here properly. So on the renew, we have the new service, a subscription box into the subscription contract with our new monthly fee or weekly. These tokens are preserved box, and we're sending the entire fee to the service here on the renewal. They don't have to do anything to collect. It happens when users renew. All right, here in the Explorer. Come on, mempool. With me here. There we go. Okay. Let's see. Tokens are preserved. These dates are adjusted. Start and end dates should be different than the input. I just can't see them yet. Once it settles, we can check that. We'll wait for it to settle. All right, we've renewed successfully. Balance went down. The new start date of March 4th. End date, let's look at the transaction. So our input, here was our start, previous start, previous end. So this should be the same as the output here. Boom, there we go. Propagated and tokens were sent as well. Okay, if we check our service wallet here, balance. Hey, we got paid again. Sweet. Okay, perfect. Okay, so this one hasn't technically started yet. So it kind of depends on how you would enforce the, I guess what you want to say, what is a valid subscription to authenticate it. For instance, my implementation just looks for the token and the end date, because that's what's enforced in the contract. The start date really is just more for reference. But so this would need to change, for instance, if you wanted to have an ongoing renewal and you wanted to keep track of, or you wanted to enforce a start date, for instance, that would have to be modified, but that can all be done on an individual level. Okay. Well, let's cancel this one that we don't need anymore. Should be a full refund. Yeah, so the only thing we're sending to the service here is our tokens, our unique subscription token, and the tokens in the subscription box. We're getting our full ERG back. But like I said, this can be a problem because technically it has paid up through tomorrow on this particular instance. But that's stuff that will need to be hammered out later. All right, so when this one settles, actually before this settles, let's check our wallet real quick. So this one's still active. All right, well, that is basically it. User. One more subscription. We do need. Now we still have this one version, but got our ERG back. Okay, so that's the basic presentation. So that is Sigma subscriptions. Going forward, everything's open source. See it all. Contracts, transaction builder. That's all in the Git, which is linked in Discord and shared elsewhere as well. Going forward, I think what's next is token payments. So you could do SIG USD, for instance, probably is the most obvious implementation. But if you wanted to, I don't know, you had a game and you wanted to run your own token and wanted to make sure people pay in that token, I don't know. There's multiple implementations that could be used for. But that is it for now. So, a lot of fun to build. So Ergo's pretty cool. Interact with it. It's definitely a learning process, but fun, and hopefully somebody uses it. That would be cool. I kind of have a couple of my own ideas that I might implement with subscription backing it for the monetary instead of launching your own token, which I think other people have pointed out seems a little unnecessary in some instances, or a fee structure would maybe work better. Alrighty. Talk to you guys later. If you want to reach out or have any suggestions or whatnot, hit me up on Discord. Later.